Let's take a look at the buzzer speaker demo LabVIEW project. I have the speaker connected here through its interface circuit, and it's being controlled by the pulse width modulated output. The front panel has a single control. You can vary the frequency of the pulse width modulated, or PWM output, all the way through the audible frequency range. So you should be hearing a tone at this frequency. I'll hit stop to break out of the program. It's based on the Pwm block from the myRIO subpalette. You have a number of PWM channels to work with on each connector. You can set the frequency either internally or externally, as I'm doing right now. If it's internal, you can simply dial up the constant. Same thing for duty cycle. It can either be done externally or internally. Again, the PWM waveform is a square wave that's being sent out to the speaker. Take a moment to talk about the Pwm block itself. The waveform is continually generated by the FPGA fabric. That means it doesn't matter how often you call the express VI. It's always generating that waveform according to your specification. Again, I'm using a constant of 0.5. That's 50% duty cycle. And here's the connection back to my front panel control. The while loop is really doing nothing more than polling the front panel control. Right now I'm doing so at a rate of 1 kilohertz based on a 1 millisecond loop time. You could slow that down just a little bit if you like. I'm ORing the air cluster with the stop button to break out of the loop, passing that through the simple air handler, and finally finishing off with the software myRIO reset.